Trigonometry, Chapter 5, Trigonometric Identities, Section 1, Fundamental Identities, Video 7, Rewriting one trig function in terms of another, Example 2. The series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In this one, we're going to do the same thing we did in the previous video. We're going to write one trig function in terms of another. In this case, we're going to write cosine of x in terms of cosecant of x. But unlike the previous video, and just to remind you, here's what it looked like. When we rewrote tangent in terms of secant, we could connect them immediately because we had one identity that did that. It was a Pythagorean identity. But for this one, we do not have one trig identity that directly connects cosine and cosecant. So just like the value questions, we are going to have to build a path from cosine to cosecant. Let's start by thinking about what we know about cosine and what we can connect it to using identities. That was supposed to be an x. Let's just pretend it is. We can use a Pythagorean identity to draw a connection between cosine and sine, or we could use a reciprocal identity to draw a connection between cosine and secant. But which of those has a more direct path to cosecant? The answer is sine, because if we did a reciprocal identity on sine, then we could get to cosecant. Is there a connection between secant and cosecant? Not directly. We have no nice identity that connects the two. So our path is going to be, we're going to turn cosine into rewrite cosine in terms of sine using a Pythagorean identity, and then rewrite sine in terms of cosecant using reciprocal identity. So let's give that a try. Remember, we're going to go cosine. Whoa, I'm not sure what happened there. We're going to go cosine. Okay, I'm not sure. See, this is what I get for trying to change what I do. We're going to go from cosine to sine to cosecant. All right, let's erase all this in the middle. Eraser. And let us begin. All right, so we're going to start by writing down the Pythagorean identity that connects sine and cosine. Now, at that point, we have a couple of options on what to do. Let's start by writing that identity down. It's sine squared x plus cosine squared x is equal to 1. Now, at this juncture, we could go ahead and solve for cosine and then replace sine with 1 over cosecant, or we could replace sine with 1 over cosecant right now. Either one would be okay. I'm going to choose to change sine to cosecant right now because at some point I'm going to have to square root both sides, and I think I would rather make the substitution before than after. Maybe that's not the best of reasons, but it's the reason I'm going to go with. I know that sine is a reciprocal of cosecant, so I can rewrite sine squared of x as 1 over cosecant squared of x. And I could go ahead and square both sides of that, so let's just go ahead and make that a little bit cleaner. We will square both sides of it. Of course, 1 squared is 1, and cosecant squared is, that's not what I meant to do. 10, please. 1 squared is 1, and cosecant squared is cosecant. So we just reciprocated sine squared to get 1 over cosecant squared. Now, if we subtract that from both sides, we'll get cosine squared of x equals 1 minus 1 over cosecant squared of x. Now, at this point, we could just put a big O square root around it, but I'd like to try to simplify the right side a little bit before we do that. If I can get this thing to work. Cosecant squared x. So what can I do to the right side to make it look different? Well, combining the two fractions would be a good idea. Now, it doesn't look like two fractions, but we could always write the first one as cosecant squared over cosecant squared. And then minus 1 over cosecant squared. So that way we have a common denominator. We have cosine squared of x is equal to. On the top, we would get cosecant squared of x minus 1. And on the bottom, we would have cosecant squared of x. Now, was this beneficial? The answer is yes, and here's why. When I drop a square root over both sides, it will cancel the square on the cosine. Bring in a plus minus. And think about splitting up the square root across the fraction here. On the top, nothing would happen because of the minus. So I would have the square root of cosecant squared of x minus 1. But on the bottom, when we square root the cosecant squared, we would just get cosecant. We can't cancel the square on the top because of the -1, but because the denominator lacks the -1, we can cancel the square. If our goal was to write cosine as a function of cosecant, we've got it. Again, could we have just come up here and square rooted both sides of this and be done with it? We could have, but I honestly think that this expression looks better than this expression. Because in my opinion, when you're doing a calculation with a fraction, it's best to hold off the fraction until as late as possible. And the bottom expression does that.